Hey everybody, it's the Laser Wizard, and we've got a nice surprise today. FoxAlien sent me their latest iteration of their laser machine called the Reizer. And despite somebody spilling their coffee all over it, everything inside I think looks still pretty clean. I haven't gone through it quite yet. We're gonna do that together on camera right here. So first thing we have is the user manual along with the parts list. We'll go through that later. All right, let's see what we got in here. This is the x-axis. Gonna need to tighten up the V-wheels just a little bit. They're a little loose, but it's got a very nice Z-axis adjuster here. Very nice. Comes with some nice warnings and the logo, and with part of the drag chain already pre-installed. In fact, I think that's the only drag chain on here actually. Here is the left y-axis, and it has the control board bolted right onto it. So we'll see how well that works. I don't think it'll be a big problem. It comes with homing switches. At least just the one homing switch for homing it. Does not have a maximum limit switch. And here's the other axis, the other y-axis on the right. This time around they're including red goggles instead of the green. Hopefully these will be a little bit better. Pretty nice looking USB cable with ferrite chokes on both ends. Hopefully that'll help with communication. We've got a 60-watt power adapter. Two 2020 V-slot rails. And I think most importantly, a nice 20-watt laser module. With a positioning block. 20 watts, about 5.5 watt optical out, I believe, and a fixed focus lens with, I believe, their beam compression technology. And then the focusing block goes from the heatsink to the surface of your material, makes it very easy to focus. And the last thing I believe is the adapter bracket to bolt this on. So next we'll get on to assembly. So it's funny, I already had this box. I put all the packing back in it. I was about to chuck this box out and I shook it and I heard something rattling in there and I missed something very important right here. And it's all the hardware. And what looks like a very nice looking thumb drive. and the tools. Okay, plus some pretty nice looking sample plywood pieces. We'll see what we can do on these. Alright, I hope now we got everything out of the box. Alright, this is all the parts that come in the box. Step 1 and step 2 of the assembly involve pre-assembling some bolts and some T-nuts. M5x10 button heads and some T-channel nuts, and we just want to get them on nice and loose. Okay, now that those are on nice and loose, step 3 is sliding on the X-axis profiles and bolting them down with the M5x25 hex socket head bolts. Alright, and I'm tightening this bolt first so that it pulls it in as much as it can. And then I'm going to tighten up this bolt right here. And we're going to repeat that on all the next 3 corners. Step 4 of the assembly is attaching the X-axis gantry. We're going to need 4 button head bolts M5x20. And we're going to have a little bit of an extra step here. Now I've already done this to both of the Y carriages because both of them were a little loose. This one was just a tiny bit loose. That one wobbled a little bit. What's very important is that for every carriage, before you assemble it, you check to make sure that its wheels are nice and tight. It might be hard for you guys to see it, but maybe you can hear it. There's a little bit of looseness between the V-wheels here. So I'm going to loosen up the bottom bolts here and just squeeze them and re-tighten this bolt, and hopefully that'll get rid of the slop. I'm using a wrench on the bottom nut, and then I'm loosening this bolt just enough to give it some wiggle room. And it's a little tricky. You gotta hold we're gonna have to find a better way. Alright, this makes it a little easier. I slid the rail all the way to the end. I'm gonna put this wrench on the nut, and as I'm tightening it, I'm gonna be pulling this bolt down as well as the wrench down there. Now we're gonna try and do the other side. Okay, and that is perfect. Now there's no more jitter. Now that we've made sure that all our carriages are nice and firm, this one does not jitter at all, but it moves nice and free. Now we can go ahead with assembly. The Y2 cable is already put through the extrusion, so as we're putting that on, we have to make sure we feed these cables through the little slots before bolting it down. Alright, now I'm going to leave these loose so that we can have some wiggle room for the other side. This side might be a little tricky because we got to get this cable through this hole without pinching it between the plastic plate here. Yeah, that wasn't bad at all. Okay, so I unplugged the left Y-stepper motor cable just to get better access to the bolts. I'm going to plug that back in. We'll go ahead and plug the Y-axis motor in right next to where the Y left one is. I think that's in there. And we've got the X homing switch goes right here. The laser head is right here on the left. And then the Y-axis motor is the last one here. Next step is to bolt the acrylic plate to the back of the laser module using the tiniest bolts in the set. These M3x8 bolts. And they go right on the back of this laser module. All right. Makes it very easy to swap laser modules later. Alright, the last physical step, number 6, is to bolt the module right up onto the Z-axis using the M3x8 socket cap bolts. Gotta make sure we plug in the laser module right here. And I believe that concludes the entire assembly and the wiring. We've got the Y-axis motor plugged in back here, laser modules plugged in here. We've got our right Y-stepper motor and our left Y-stepper motor all that remains is the USB and the power cable. And some people have expressed some concern about having the module mounted on a moving axis, and I was a little concerned at first too, because you definitely don't want your USB cable nor the power cable to be moving or flexing, because that'll eventually guarantee lead to connectivity issues. However, I don't really think it's going to be an issue as long as those cables are zip tied firmly somewhere over here. That way that as this thing's moving, these cables do not budge at all. So I'm gonna get onto that step next. I'm gonna see how we can mount those cables rigidly. So I've plugged in the USB cable and the 12-volt power supply. The way that I've personally routed them is I have them loop up and over, and I've got one zip tie right here going through the standoff and through both cables, and then these cables run underneath, and then they're also zip tied on the back here. That way if there's ever any flex here, I mean there's bound to be, these cables here aren't getting flexed. This carriage can move back and forth, and there's absolutely no movement happening on these cables, and that's very important, or else you'll definitely have connectivity issues. So that's a very simple solution, and I kind of like having this control board here. It made the wiring super simple. It removes an entire drag chain. The previous machine, the LD4040, had a drag chain here. This makes it a little bit simpler, just the one drag chain and very short and simple wiring harness. Now we are on to the software end of things here. After we've checked over all the wiring, then first step is going to be installing the drivers, and I believe they do come on the flash drive. We'll actually check out the contents in a bit, but if it doesn't work, then you can download it straight from the manufacturer website, which I recommend if you have issues, but the one included should work fine. Now my laptop should already have the driver installed. It's not my first GRBL machine, so we might just skip over that step. Next, we'll just plug it right into the USB. And what I recommend is you go into Device Manager, and you gotta click on Ports. Right there it says we are on COM4, and that's very important, or else you'll have trouble connecting to it. So we're opening up LaserGRBL, and it's already set to COM4. We're going to turn on the controller. We're going to see if we can connect to it. Alright, looks like we've made connection. First thing I'm going to do is I'm going to type in $$ and hit enter. This gives me a readout of all the current GRBL configuration parameters. It's very important that you get familiarized with these parameters. They can greatly help identify issues and problems. Most important ones I look at, $110, 111, and 112 are the X, Y, and Z max jog rates, and here we're at 20,000 millimeters a minute, and that's pretty darn nice. $100, 101, and 102, those are the steps per millimeter, and on the Reizer, on its 32-bit controller, it has twice as many steps per millimeter as the LE4040. We're at 160 here. Another important parameter is the laser mode. The previous machines, most of them by default did not come with laser mode enabled. It's very important that $32 equals 1 if you are lasering. The next very important parameter is $30. On the laser machines, that's usually set to 1,000. On here it says spindle max RPM. What this is your S max value, and it's just important that you know what this number is when you're using LaserGRBL or Lightburn. It needs to know what your S max value is. If you have a CNC router, $30 is usually 10,000 on those, which is fine. You can leave it there, but you have to change your S max in Lightburn and LaserGRBL to match that S max value. Down here, 120, 121, and 122, those are the acceleration values for the X, Y, and Z. I've played around with those before. I've increased them a little bit. We'll see if we can increase them on this machine later on. So right now I've got my machine turned on and it's connected, but I can move it, and I really don't like that, because what happens is, what that means is when your steppers are idle, they're not locked and they're loosey-goosey. The next time they're re-enabled, they might jump and they won't be in the exact same position they were in before. So there's a setting I like to change, and I'll go ahead and change that right away. But it's $1. On here it's 25, and that's the step idle delay. And if you change this value to 255, then it holds them steppers solid or locked even when they are idle. So let's try that right now. We're going to type in $1 is equal to 255, and we're going to hit enter. And then we're going to type in $sign again, and we'll scroll to the bottom. So right here we see where I've input that code, and right away we can see $1 is equal to 255. And let's see if that's made a difference here. Nope, not yet. Maybe we need to power cycle it. So that's interesting, they are not locked. Yeah, so that's very interesting. The first time I powered this machine on, it did have all its steppers locked, but I did not have the USB cable plugged in. The second time I flipped it on, everything was loose. So I'm not sure what that is, if that is just a setting in the firmware, but it's not that big of a deal. It should still run fine. We'll see if we can figure that out later. Down here are the jog controls. Now let's see if we can increase this feed rate. We're at 8,000 now. It's moving pretty quick. Let's increase the step amount to 100. Okay, let's set the feed rate to max, 20,000. Moves really nice. I'm gonna increase the acceleration values later, but it could probably benefit from higher acceleration rates, especially if we're gonna be doing high-speed raster engraving. Let's see if the laser will turn on. I'm gonna put on my safety goggles. And there we are, we get a beam. So we might be ready to set up our first laser engraving. Let me go get a little cutting bed, and I'll put a piece of scrap on there, and we'll go through the focusing procedure. So since I don't have the FoxAlien honeycomb cutting bed yet, I'm using this old aluminum condenser that I used to use way back in the day. And this is just gonna act as my cutting surface. That way there's minimal surface area to let all the smoke out. And since it's so thick, I had to space it up with these boxes. So I just stuck a box of equal height under every corner. Just a quick fix to get enough space below the laser module. And what I'm gonna do, I'm gonna try on one of these sample pieces to make an engraving and maybe even a cut. So focusing the fixed focus 20 watt module is very simple. Focal distance is 30 millimeters, which happens to be what this cylinder here is. And then you just use the knob and you bring it down. Until it touches. And that's how you know you're in good focus. We're going to attempt to engrave this FoxAlien logo. I just opened it up from the flash drive, but we're going to try and do one bit different. We're going to go up to 10 lines per millimeter, horizontal engraving. Let's try Jarvis. Might come out a little textured, but that's okay. Well, let's try the default Floyd Steinberg. Next, and right here, got some important settings. Engraving speed, I'm gonna try, I've not used this machine with this laser before, I'm gonna try 5,500 millimeters a minute. And we want to do dynamic power, full laser power, we'll just keep the size as is. So right now it's generating the G code based on the parameters we've put in. And for whatever reason it is not showing up in the preview window. Oh wait, there it is. There we are. So estimated time is 3 minutes and 49 seconds. I think we should be alright. We'll see how it comes out. One thing I really like to do is to frame it. The frame button there. I'm going to make sure I put on my goggles first. So earlier I changed the $1 value to 255 to keep the stepper motors locked when idle, and that change didn't happen right away, but now after a couple of resets the laser module doesn't budge, and I recommend it that way as you're going between cuts and between layers, it holds its position, because when you disable and enable the steppers, they don't always jump to the same step. So now that I've got the machine on, I'm going to click the frame button. It is not going where I expected it to go. So what I'm going to do is I'm going to jog it to where I want it to be. Now that it is where I want it to be, I'm going to click the set 0 point in Lightburn. I'm sorry, in LaserGRBL. That's this button right down there, the globe. That sets the 0 point, so now this arrow shows 0, 0, and that's where we want this piece to be. And it's just a rough estimate. I mean, we're just testing this right now. It doesn't have to be perfectly on center. We'll see how it frames it now. The other thing I didn't like is how long it took to frame it. So let's see if we can change that. If you right click on frame and edit button, it shows what the feed rate is, and they have it set to 1000 millimeters a minute. We can change it to, let's make it 6000. And let's see how long it takes to frame it this time. So I think we can maybe shimmy this over a little bit more into the corner. Frame it again. Let's move it over to the left. Okay, I think it'll be okay right there. We're just gonna send it. We'll see what it can do. Okay, that came out pretty nice. Let's jog it out of the way. All the lines are very nice and crisp. The eyes, the ears, and the nose are deeper than the rest of them. It looks real cool in the shadow. Alright, this is the very first attempt with the Reizer, and honestly it ran very well. The steppers ran very quietly. The drivers must be pretty silent. We'll see what we can do next. So I want to cut this shape out, but I've already moved it, so I've lost my reference point. I'm going to show you guys how I usually go about finding my way again. So right now I've double clicked right on the tip of the nostril. So as you can see, the laser machine thinks it's right there on the tip. So I'm gonna click the focus button, and that turns on the laser beam low power for focusing. But what I'm gonna do is I'm gonna move it to the very tip. What I'm gonna do next is I'm gonna click on the very tip of this ear, double click, and the laser thinks it's there. I'm gonna click focus again. I'm gonna try and triangulate my way back to having this thing lined up perfectly. I'm gonna click it to the tip of the other ear now. And then back to the nostril. Okay, I'm very happy with that. I think we've got it lined up the way it should have been. I created a special file to cut this out with. I'm gonna try and attempt to do this cut with no upgrades, just as is stock. And then later on I'm gonna try and do something similar with the upgrade I highly recommend. We'll see how that comes out. Let me go get the file and I'll show you how I set that up. Alright, let's open up that file I created. And it's this one right here. So all I've did was I've outlined the logo, the words, and I've drawn some connecting lines between them. And what we're going to do is we're going to vectorize it. And what that does is it outlines everything, and these will be the tool paths. We're going to do no filling because we just want the outline. We're going to click next. And so here, for cutting, you can do constant power. That'll help the corners cut through better. For the border speed, I'm going to do 400 millimeters a minute. And we'll see how many passes it takes to do that. And the size I'm going to keep the same. And I'm going to do it full power, 100%. So that previous estimate was very off. I have to figure out why. I need to see, maybe LaserGRBL needs to update its acceleration values or something. But it did not. It took like 15 minutes to do that engraving. Here it says 1 minute and 43 for this cut. But what we're going to do is we're going to set the number of passes. I'm going to set it to 5. We'll see if it can do it in 5. And this is with no air assist. We'll see how it does. No, it's not quite through yet. So what I've noticed is this laser constantly kept cutting in and out. And I'm not sure why. So we'll have to run some tests. So I ran a couple more tests with Lightburn and then again with LaserGRBL, and I believe I was just not giving it enough passes, because I was able to cut these 2 holes pretty easily. So I'm going to try and run this original file one more time on the other sheet that they include. However, I'm going to upgrade to having air assist. And this is my Laser Wizard Air Assist nozzle. It's designed to go right up on the factory FoxAlien 20-watt laser module. And such a snug fit, barely even need the set screw. So I'm going to go ahead and show you guys how I go about upgrading this. Right over here is my air pump, 32 watt. Any lower than that and you're gonna have worse results. And I've got this 1/8 inch ID tubing that I'm gonna fish through the drag chain in a moment here. And on the other end, I just stuck this hose into a bigger hose to help me stick it on this big fitting on the end here. So I'll show you how I do that right now. Alright, the way I'm going to do this, I'm going to fish it from the y-axis side over here. I'm going to start by slowly moving this all the way to the right. And I kind of like to use the curvature of this tube to help me guide it through. So I curve it up, that way I could just, in every section, push it down. And then once you get as far as you can go, then you can slide it all the way to the left and keep pushing it. So we found a spot that we're stuck on. I think we just gotta move the cables over. There we go. And that wasn't too bad at all. So I'm going to pull it out to have enough to comfortably reach the range of the Z adjustment on this module. And then the other end, we're going to plug in to the air pump. Okay, that should be good enough. Installing the nozzle itself is very straightforward. You just need an Allen wrench and not much torque. You just want to hold it in. But I recommend to put the tube on first. It doesn't have to go on very far. 1 or 2 barbs is plenty. And then it's a pretty tight, snug fit. But it goes on, and then if you just grab it by the short end and give it a little tug, that's all you need. Works pretty good. So let's see how it'll cut now. Alright, I'm going to attempt this a second time using LaserGRBL. I have opened up the same image file. This time I've chosen the Sierra 2 dithering method. We'll see how that comes out. I raised the brightness just a little bit, just to give it a little bit more contrast. But I'm also going to speed it up, so I don't want to lighten it too much. So on the next window, I set the engraving speed to be 6,500 millimeters a minute. M4 dynamic power, S-max of 1000 for full power, and I've taken this and I've measured it, and it's about 100 millimeters. So that's what I put in for the height here, 100, and it set the width to be about 92. The image here is not square, whereas these are pretty square. But once we go to align it up, I'll center it up. So I'm going to create it. Alright, and there we are. One more time, it says 3 minutes 45 seconds. I believe it's gonna take longer than that. I'm not quite sure just why yet, but I'm sure we'll figure it out. So I'm gonna turn on the machine. I think that came out fantastic. The eyes are much more defined, they're much darker than the first one. I'll show a better comparison of the two later. But look at that. I ran it faster and I brightened the image a little bit. And that's because the air assist really helps the flame burn much brighter and much, hotter. Gives it that oxygen to keep that reaction going. Plus, blowing straight down, it kind of helps that soot get embedded down into the wood to help create that dark color. I'm not going to touch anything. I'm leaving it as is. The laser returned to the origin, and now I want to run the cut file. So I'm going to go into File, Open, and I created my cutout file right here. And I'm going to pick Vectorize, and it outlines it. I'm going to click Next. And we're going to, let's maybe keep it dynamic power. 350 millimeters a minute, 1000 S-Max for 100% power. And we're keeping the size exactly the same. That way it gets cut in the right exact same spot. And I'm gonna run it. Let's do 5 passes. I'm not 100% sure how many it'll take, but I want to make sure I make enough passes. Alright, I'm gonna turn on the air assist and I'm gonna run it. Let's see how that came out. Very tight. But man, I think that looks good. On the left was without air assist and 5,500 millimeters a minute. On the right is with air assist, 6,500 millimeters a minute. And then I did 5 passes here. I'm not sure how many were necessary. Right, I've created 2 files with my Laser Wizard logo. One is an engraving file and one is a cutting file. The cut file, I just have an overlay of black color over the whole image, minus the detail in the hat, and it's stroked so that the cutout is a little bit bigger beyond what the actual engraved image is. I really like how the FoxAlien logo came out, so I'm going to make a matching pair. And I'll just run the same settings I did on this, since I like how this came out. This time I'm using a piece of maple veneer plywood that I've got, so we'll see how much differently that engraves. But the settings I'm going to keep the same. 1-bit dithering, Sierra 2, horizontal, and 10 lines per millimeter. And we're going to click next. Looks like it's set to 100 by 100. We'll keep it at that, leave it at dynamic power, 6,500 millimeters a minute, full power. Alright, and there it is. Hopefully it comes out pretty decent. Okay, and since I'm using a little bit of a thicker piece of plywood, I want to make sure that I'm still in focus here. Okay, I think that's good. It's not much thicker. But we'll do a trace just to make sure that we are where we think we want to be. I think it's good. I'm going to turn on the air assist and I'm going to run the file. A couple of these I'm going to have to poke through. Right, these are my first 2 products I've made, other than the first mistake or dud or experiment, should I say, that I made here. But it cuts very nice. It cut out the FoxAlien logo pretty good, and then it cut my logo out pretty damn well too. This is 3.5mm thick pure bond plywood, and I like them very much. Let's see what else we can do. Alright, for the next thing that I want to try, I'm going to be a little adventurous. I have taken this can of Brilliance laser marking spray metal black. This thing has been working phenomenal for me with the diode lasers on stainless steel. And so what I have done is I've taken this plate here and I've coated it with the Brilliance laser marking spray. I'm going to place that right there. Be very careful because it's a powder. And I'm going to return the laser back to its home position. I've already set the focus perfectly well with this extra piece of stainless steel here, same thickness. I used the red Sharpie on the back to mark a red spot, and then I focused the beam onto it, and I confirmed that with this spacer it was right on focus, and it is. It's actually spot on. So now that I'm in the home position, I can see that I'm not directly on this corner, so I'm going to move it there. And I'm going to turn on the beam to low power, and I can see it right there on the corner. I'm going to jog it 40 millimeters to the right. Make sure that it's right along the bottom edge. Alright, I think we're centered pretty good. I'm going to be again engraving my Laser Wizard logo, and we'll see how it comes out on stainless steel. Okay, hopefully that came out nice. This is how it looks straight after lasering, and I've got a wet rag right here. Wow, it looks pretty nice. Got a little bit of soap on here. But let's wipe it off with a dry paper towel. How cool is that? Laser marked on stainless steel. That's beautiful. I couldn't be happier. Okay, next I'm going to test out the engraving capability. I've got it set to 6,700 millimeters a minute for the engraving, and then 350 millimeters a minute, and 4 passes for cutting out the perimeter. I've already edited this file the online converter imager.com. So I've got pass-through selected here, and I've got it 8.5 by 8.5 inches, which is a good chunk of the size of this sheet here. And we'll see how well it can do grayscale portraits. So far, I'm quite pleased with this machine. Engraves pretty well, marks steel pretty good, and it can cut plywood very well too. Obviously, you've got air assist upgrade. Put together very well. The controller seems to work fine. The only thing I noticed is that I don't believe it's engraving at full speed. There might be some optimization still left to be done. But it took a little bit longer to do this bird than I expected. But it came out great. It definitely might not have been the best image to start with to show good grayscale, but it still looks very good. The 20-watt module works phenomenal. It's got a very nice beam shape coming out. I've been using the 20-watt module from FoxAlien for a couple months now. It works very well, and I've always ran mine at full power. I haven't had an issue. Overall, I mean, I'd recommend it. It's definitely a great starter machine. The Z-axis on here makes it very easy to focus to your different material heights. I'd recommend investing in the honeycomb cutting bed if you plan to do a lot of cutting, or any cutting for that matter. Definitely got to get yourself an air assist from the Laser Wizard. And most definitely you need some good fume extraction, at least a fan in the window right above the machine. But overall, very good. I'll try it out on a few different materials and I'll see if I can optimize the engravings over the next coming days. But I hope you all have enjoyed this video. I hope it's helped you get a better understanding of how this machine can work and whether or not you want to pursue getting it. I recommend it. I like it quite a bit. So thank you guys for bearing with me, and I hope you all enjoy the rest of your day.